All right, so routing and switching essentials. This is the Chapter 3 lab we've been working on. First of all, any questions you can think of? Brian, any questions? Okay, then up here, if you have, for example, these particular VLANs cannot communicate with these VLANs, or VLAN, that's a particular VLAN which can't communicate with this. They're all on different networks. Okay? Now, the switches should be able to, these two switches should be able to communicate each other because they're on the same network and they're on the same VLAN. These two devices should be able to communicate to each other because they're on the same VLAN, and if they were configured correctly. And then we run into some issues if pinging, in terms of if there's any software on the device itself that's not allowing pings. So you got to make sure that's cleared up too. The only way this device here can send a ping and have it get across the trunk and get over here is when this device comes into this network. Okay, when it comes into, it's on a network. Okay, help me out here. PCA is on which switch? Oh, it's right here. Okay, so PCA 192.168.10.3, and this is 10.4. They're on the same network. It's important to remember, does this device know it's on a VLAN? No, it doesn't. And if there is another device, let's say PCC, if these two ping each other, does anything happen to the frame? No. This port, whatever port this is, would have to be on VLAN 10, and the switch would move the information just as if it was just one switch. Now, when B and A need to ping, it goes up into the switch, and it finds that the MAC address for this is on this port here. So what happens when it has to cross the trunk, in layman's terms? Or technically, what happens? What happens at the port? Because when it gets over here, it has to be on what? Is this a hint?
Tags it.
Tags it. So it gets tagged here, so that when it gets over here, it looks at the tag, which is literally the number 10 plus a bunch of other digits, or 10's at the end of all the digits. It's a number with the number 10 is actually in there. When it gets over here, it takes that tag off. Now it's in the switch fabric on VLAN 10. So then it finds a port based on the MAC address. Now, if there are, okay, so for example, we have two switches over here, or two PCs over here on VLAN 10. If PCA wants to ping C, goes into the switch, this port here, where the trunk is, it would know that this is over on the other side. Does that make sense? It has those MAC addresses, right? This would have, if there were 15 computers over here, we'd have 15 MAC addresses there. It's got to be able to find where to go. So it looks at the MAC address, says it goes this way. Then when the frame gets put on the trunk, it just puts a tag in it. the size changes, it has to reconfigure the frame check sequence, and sends it across. When it gets over here, the tag is tore off, but it's already on the correct VLAN. Maybe I'm being oversimplistic, but then here, VLAN 20 cannot ping either one of these devices because they're not on the same VLAN, and also they're not on the same network. Any questions on that? So, the only value in these two addresses in the switches is to do what? Remote management. And the only way you could remote manage this is if you have a workstation on what network?
Same
192, 161, 168, 111. These workstations cannot telnet into the switch because they're not on that same VLAN. They've got to be on that VLAN. Or you have to have some routing device to switch you to that VLAN. Or you'd have to have some routing device to do that, which we learn in Chapter 5. We talk about routing in Chapter 4, and then Chapter 5 we do the inter-VLAN routing. Okay, so just in review, we have lots of reasons to use VLANs. And then we have some of those definitions of virtual VLAN. Okay. Broadcast domains. Partitioning of a layer 2 switch. The host group within a VLAN are unaware of the VLAN's existence. Beat that to death. A lot of places run a separate VLAN for voice. They just run that on a separate VLAN, so the phones are connected to those particular ports. We just talked about how important trunking is, and a big issue there is if you have an older Cisco switch that runs ISL tagging. That's an older method of tagging. So if you have an older switch that its default is ISL, and you have a new switch that's the .1Q, you're going to have to take this switch and reset the encapsulation to .1Q. You get it? Then they can communicate. Last thing I'll mention, dynamic trunking protocol in the curriculum. You can take a look at how that works, Cisco proprietary. So your devices are connected, so you can work on, rest of today we'll work on the labs. You can work on those labs remotely. On Monday, we're going to take a look at the labs. We'll review a little bit of this particular chapter, and then we'll take the assessment on it. And then we'll come back and look at Chapter 4, and at the end of the day, Monday, we'll take the pre-assessment for Chapter 4. And I have that in the curriculum. Any questions you can think right now for the good of those guys that are gone, so I'm going to send them this recording. You really have to get in here and get workstations on to really see it work. But you can do all the configuration and at least see the trunks come up. All right.